Okay.
And it'll all say recording. And you're ready to go, Carl. Welcome.
There's my screen. I'm going to be recorded. Okay, let me make it full screen here. It'll get there eventually. Yeah, there it is, for me at least. Let's see here. So it's full screen over there. Boy, there's lots of
looking good.
Looking good. Okay. Let me minimize the picture, the images. Well, I'm Carl, K9LA in Fort Wayne, Indiana. That's up in the northeast corner of the state, kind of close to Michigan and Ohio. And we're pretty far west, but we're still on Eastern time. So it's 10:30 here. Today, I'll talk about some basic propagation stuff. I could go on for quite a while, but hopefully I'll give you a good introduction. I plan to send a PDF of this presentation to Mark. And also, if need be, I could add some new slides in that PDF for the 3Y0J guys. So if you're interested, sound like you were talking about it. So I'll probably do that.
Thank you.
So here's what? Anything? Oh, okay. So here's the agenda. We'll talk about cycle 25. Where's it headed? Talk about space weather and propagation, all those parameters and all that stuff. Then just a general propagation forecast for 2023 by the bands. And I thought I'd add something to spice up your operating activities this spring through fall, a 10-meter long path. And it should apply to 15 and 12 meters too. I don't know if any of you remember John NT5C, anyone? He was down by Austin and he had some.
Texas is a whole nother country.
Oh, okay. Okay. Yeah. Oh, okay. Why are you guys called South Canadian?
There's a river around here called the Canadian River.
Oh.
And we are on the south side or the south end of that river. And that's what it was for the local area. We get a lot of people from Canada trying to join. We take their money and say a lot.
Yeah, there you go. Good idea. Okay, so I'll end up with some 10-meter long path and then a quick summary. So cycle 25, it's always good to go back and look at history. So here's an Excel plot of the maximum smoothed sunspot number for all previous 24 solar cycles. Cycle 1 began in 1755. No, I wasn't around yet. Close, but not too bad. I'm sure most of you have heard of the Maunder minimum. That was 1645 to 1750, and that's when we had few sunspots. So if we had radio back then, the higher HF bands would have been extremely poor, but thank goodness we didn't have radio yet. Why did cycle 1 begin in 1755? That's when the scientists figured we had good enough data to drive a stake in the ground. Of course, the Chinese have been observing sunspots for a couple thousand years before that, but we just didn't have good, consistent data. It all started about the mid 18th century. Now, what's quite obvious by that plot is we've gone through 3 periods of big solar cycles. For example, cycles 1 through 4 were big, cycles 8 through 11 were big, and cycles 17 through 23 were big. Now, cycles 17 through 23, that encompassed our lifetimes. So that was great. That gave us great conditions on the higher bands. Since we've gone through 3 periods of big solar cycles, it also says we've gone through 2 periods of small solar cycles. Cycles 5, 6, and 7 were certainly small. In fact, cycle 6 is the smallest in recorded history. Cycles 12 through 16 were a little bit bigger, but they still didn't get up to what those 3 big periods were. So with cycle 24, which was the last one, we appear to have entered a third period of small solar cycles. And that's the big question. Is the sun going to continue this pattern of big solar cycles, small solar cycles, big, small, big, and now small? Or is cycle 25 going to get us out of this third period of small cycles? I've also annotated some of the cycles on there. In red, there's cycle 19, the biggest in recorded history. It peaked in 57-58 timeframe, 1957, 1958. And there are legendary reports of working DX on 10 meters around the clock with low power and modest antennas. So will we ever have another one of those? Oh, it's possible, but I don't think we're going to be around for that. Cycle 21, that one peaked in 1979, and it was a moderately big. Wasn't as big as cycle 19, but it sure gave us great propagation on the higher HF bands, 15, 12, and 10, and also 6 meters. Now, if you take an average of all those 24 cycles, that comes up to what cycle 23 was, pretty much an average cycle. And then there's that in green, the small cycle 24. It's the smallest in our lifetimes. And it's the fourth smallest in recorded history. So there's a little picture of history, and let's just look at how cycle 25 is doing right now. Solar min was in December 2019. And we currently have 32 months of smooth sunspot number data since solar minimum. 32 months, that's about 2.5 years. So we're more than halfway up cycle 25. How high it's going to get, well, we're just going to have to wait and see. Cycle 25 is the big thick red line, okay? And I've also plotted 3 other solar cycles. The green one is cycle 24. Remember, that's a very small one. Orange, the average cycle, is cycle 23. And that moderately big solar cycle, cycle 21, is in blue. So if you had to draw a conclusion from that data, you would have to say that so far, cycle 25 appears to be tracking the small cycle 24, but there's still time. January was a good month for solar activity. It helped confirm that maybe we will get up to an average cycle. So far, February, well, the first week was not very extravagant, but the last couple of days have been very good in terms of sunspots and a 10.7 centimeter solar flux. So there's hope that cycle 25 may get up to at least an average cycle. I don't think it's going to get any bigger than that. Now, right now, we have enough extreme ultraviolet radiation from the sun to have 15, 12, and 10 meters open worldwide. Now, EUV is the true ionizing radiation for the F2 region, and sunspots and solar flux are just proxies for EUV. So let's look at space weather and propagation. I should mention, maybe you're familiar with Dr. Scott McIntosh's prediction. He's in Boulder, and he was one of the predictions that were for a very high solar cycle. And that prediction came out in June of 2020. And it was going to be probably not as big as cycle 19, but not too much below it. Now, in August of 2021, though, Dr. Scott and his colleagues revised their prediction for more of an average solar cycle. That's because something that they had expected to happen didn't happen when they thought it would. So right now, Dr. McIntosh and colleagues are predicting an average cycle. So I think that's still within the realm of what could happen. And that's what I'm rooting for anyway. So space weather and propagation. It's good to talk about the development of the model of the ionosphere, because that's how we understand the ionosphere. What we would have liked to have happened is to discover a correlation between a daily solar parameter, for example, sunspots or 10.7 centimeter solar flux, and what the ionosphere is doing today. That would have been ideal, but that didn't happen. The correlation was quite poor. Now, why was that? Well, we've come to learn that there are three sources of variability of the ionosphere, and we only really understand two of them. We understand solar radiation. We have three parameters for solar radiation. We got sunspots, 10.7 centimeter solar flux, and extreme ultraviolet radiation measured by satellites. The other one that we understand pretty good is geomagnetic field activity, which determines if the F2 region is disturbed. A less polite word would be screwed up. And we have parameters for that, the K index, the A index, B sub Z, and solar wind. We'll get into the descriptions of those parameters in a later slide. Now, what we don't understand, but it contributes to the variability of the ionosphere, are events in the lower atmosphere coupling up to the ionosphere. You know, we're talking hurricanes and earthquakes. That's at ground level. We don't have any parameters yet for this third source of variability. What it all comes down to, it's really tough to make a daily model with data from only two of those three sources. So that's why we can't come up with what is the ionosphere doing today based on the parameters we have. So what did we end up with? We ended up with a monthly median model of the ionosphere. Median implies 50% probability, and that correlation is to a smooth solar parameter, which is a very long-term average of daily data. So that says our understanding of the ionosphere is statistical over a month's time frame. In other words, if we have today's solar flux or sunspot number, that's not going to tell us what the ionosphere is doing today. We can get a general idea, though. Now, our propagation predictions like VOACAP, W6EL prop, and there's some others out there, give monthly median maximum usable frequency, MUF, and monthly median signal strengths. So what these median numbers are, what these numbers are medians, and there's a distribution about these median values. And what that says is the MUF on any given day in the month could be somewhat higher to much lower than the median. The signal strength on any given day in the month could be somewhat higher to much lower than the median. Unfortunately, we don't know which days are going to be the good ones and which days are going to be the not so good ones. And of course, the best way is just to get on the radio and listen, or look at some of the real-time propagation websites that we'll talk about here in a little bit. And just want to stress that plugging in the daily sunspot number or the daily 10.7 centimeter solar flux won't make the predictions more accurate. So maybe one of these days we'll have daily predictions, but it could be quite a way off. Now, here are the parameters that I consider important in order to get just a general idea of what propagation is like. And earlier I mentioned SN, sunspot number, SFI, solar flux index, EUV, extreme ultraviolet radiation, the K index, the A index, B sub Z, and the solar wind. One place to get them is from the N0 NBH banner at qrz.com. And I pulled this morning at 8:30 your time, 8:30 Central. You can see the SFI is very, very high. Sunspot numbers up there. A is 16, K is 2. Like I said, we'll go over a description of those parameters and also what their range is, so we can kind of see what's kind of get a general idea what's going on. What I'm going to concentrate on is just five of those parameters: sunspot number, solar flux, K, B sub Z, and solar wind. Now note on that N0 NBH banner, there's a MUF at US boulder parameter at the bottom. That's pretty much a real-time indication of what's going on. It's the maximum usable frequency over the boulder ionosonde if it was the midpoint of a 3,000 kilometer path. It so happens that a path from W6 to the Midwest is about 3,000 kilometers. So that's a good indication of what bands might be useful. At 8:30 this morning, it said 15 meters was probably open, nothing higher. It will be higher during the day because sunrise wasn't fully up yet. So there was not enough ionization for the higher bands yet. And again, these parameters should give you a general idea of what propagation is like. And here's a description of those parameters, which will help you make that decision. For example, SFI, the daily 10.7 centimeter solar flux, it ranges from 65, that's solar minimum, up to about 350 at the maximum of a big solar cycle. So let's go back to what the solar flux is today, 208. Well, that tells us that we're quite away from solar minimum. So that's good for the higher HF bands, 15, 12, and 10 meters. We're still not up to a big solar maximum yet, but we probably won't get there, but it's going to go higher probably. Sunspot number, that's the daily sunspot number. At solar minimum, it can be 0. In fact, our last solar minimum between cycles 24 and 25, we had many, many days of no sunspots on the sun. And the sunspot number for a big solar cycle could get up to 450. Let's go back to the previous, the N0 NBH banner. Sunspot number today is 213. So that says, well, we're quite away from solar minimum. And we sure saw that in the Excel plot of cycle 25's progress. EUV is extreme ultraviolet radiation. I'm going to leave that one out. We've got solar flux and sunspot number. That's enough. The K index, that's the 3-hour index of the activity of the Earth's magnetic field. Generally, when the Earth's magnetic field becomes disturbed, it'll screw up the F2 region. You'll have to move down in frequency because the MUFs go lower. It's on a logarithmic scale from 0 to 9. So let's go back here. The K index at 8:30. Remember, it's a 3-hour index, so it gets updated every 3 hours. K was 2. And that tells us that, wow, yeah, it's kind of pretty quiet. So that says the F2 region should be up to its full potential. The A index, that's the average of the 8 daily K indices. So the K index is a 3-hour index. The A index is a 24-hour index, kind of coarse. It's on a linear scale, goes from 0 to 400. So let's go back here. What was the A index? 16. Well, 16 out of 400, that kind of tells us things are pretty quiet. And that agrees with the K index, telling us that it's kind of quiet. B sub Z, that's the north-south component of the interplanetary magnetic field, which is the sun's magnetic field. It varies from about plus 50 to minus 100. So what is the Z component? The Z component is, like it says, the north-south component. It's perpendicular to the ecliptic. The ecliptic is the plane in which the Earth goes around the sun. Now think about the Earth. The BZ is north-south. The Earth's magnetic field is north-south. So that gives us a good indication if the sun's magnetic field is coupling into the Earth's magnetic field. If it's slightly negative or positive, it's not much of a problem. If it's large negative, that means the solar wind is coupling into the Earth's magnetic field, and that's not a good thing for the HF bands. Solar wind speed, on average, it's for a quiet time, it's about 400 kilometers per second. oops, let me go back to the B sub Z on the N0 NBH banner. Let's see, where is it? There it is. It's the third gold box down. It was positive 4.6. So that says things are pretty quiet, and it agrees with the A and K index. The solar wind. For quiet time, it's about 400 kilometers per second on average, and it can vary from 350 all the way up to 2000 when there's a big coronal mass ejection or a coronal hole, and that's guaranteed to not help the higher HF bands. So what was the solar wind speed today? It was 454 kilometers per second, which kind of says it's just a little bit above average, but it's not too much to worry about. So you can see the K, the A, the B sub Z, and the solar wind all correlate. If the K index is low, the A index will be low, the BZ will be maybe slightly negative to positive, and the solar wind will not be too much greater than 400 kilometers per second. Again, a general idea of what the conditions are. Now, what do we desire from those parameters? I've kind of given those clues already, but we need two conditions for a QSO to occur. One is there's got to be enough ionization. Generally, we worry about the F2 region because that gives us probably 99% of our long distance QSOs, day and night. Of course, there's sporadic E, which throws it off in the summers, but mostly it's the F2 region we really want to focus on. So there's got to be enough ionization to refract the signal back to Earth. And that means the MUF has to be high enough for the band that you want to operate on. And there's got to be low enough loss. And there's a whole bunch of things that make up loss. Those things are in the first set of parentheses. The first one's ionospheric absorption in the D region. Then there's free space path loss as the signal spreads out as it propagates from your antenna. Your antenna gains transmit power, receiver sensitivity, minimum discernible signal, MDS, and your local noise. You can work on antenna gains, transmit power, receiver MDS, and local noise, hopefully, to improve the probability that you can read a signal, or if you're using a digital mode, detect a signal. Generally, what we desire is K less than or equal to 3. And like I said, that correlates to a B sub Z positive or slightly negative, and a solar wind not too much higher than 400 kilometers per second. Of course, there's exceptions to everything. The VH types like high K indices for propagation via aurora, but we're mostly concentrating on HF stuff here. Now, for the higher bands, here's some guidelines for solar flux and sunspot number. For 15 meters, we need a smooth solar flux greater than 90 and a smooth sunspot number greater than 35. For 10 meters, of course, we need more solar flux. We need more sunspots. Now, even if solar flux and sunspot number are at their minimums, 17 meters and lower frequencies are still open. Even at solar minimum, there's enough extreme ultraviolet radiation from the sun to keep 17, 20, 30, 40 meters, et cetera, open. In other words, they have enough ionization to refract your signal back to Earth. Now, where are we right now in cycle 25? Well, the smooth solar flux is 120, which is good. And the smooth sunspot number is about 100. So that means 15, 12, and 10 meters should be open, and indeed, they certainly are. So if you don't want to mess with propagation predictions or all those space weather parameters, one thing you can do is go to one of the many sites that tells you what's going on right now. Here's DXMaps.com. I pulled it this morning at about 9 o'clock your time. And you can see North America is working Europe, North Africa, South America, almost into South Africa, but whatever. And of course, it's going to be better for you as the morning progresses because you'll be more in daylight. Notice that that's data for just 1 minute. So there are a lot of people on 10 meters, that's for sure. That's a world view. You could pick North America view, Europe view, whatever. World view is probably maybe what you're most interested in. And you can see I've circled the 10-meter band up there, and that's why it's 10 meters. The data is generated from spots, packet cluster spots. It just plots the station who spotted the DX and puts that path on the map. And you can see that 10 meters was really doing good earlier today. There's some other methods. There's PSK Reporter, WhisperNet, the reverse beacon network. That's if you transmit in a certain format, you can go listen to software-defined radios around the world and see where you were received. That should give you a pretty good idea what's going on in that band worldwide. There's the IARUNC Northern Cal DX Foundation beacons. There are 18 beacons. They run on 20, 17, 15, 12, and 10 meters. And each of the 18 beacons transmits for 10 seconds. So 18 beacons times 10 seconds is 180 seconds, 3 minutes. So in a 3-minute period, if you listen to those beacons, you can tell what worldwide propagation is because those beacons are scattered all around the world. Kind of interesting. There's also some software from VE3NEA called Pharos that syncs up your computer to the beacon time, transmit time schedule. And you can record data from the beacons around the world, and you can really see a lot of good stuff. And one of the things you'll see is short-term openings that we just can't predict yet. And a lot of it has to do with that third source. We just don't know enough about it yet. And it's kind of interesting. The ionosphere is very dynamic. And if you're in your chair at the right time, you may be surprised about what you can hear that our propagation predictions don't say anything about. Now, I also mentioned KC2G MUF map, and here it is. I pulled this at 9 a.m. this morning, your time. And what it does is KC2G downloads all the ionoson data around the world. That's what those circles are with the numbers. The numbers, those dots are the MUF over the ionoson. It's for a 3,000 kilometer path, assuming the ionoson's in the middle of the path. So you can see that probably a path from the eastern coast of North America to Europe. It says 10 meters certainly should be open because the MUF's above 28 megahertz. So that's a pretty good indication of what's going on around the world. Nice visual picture, and it complements the DXMaps, the visual picture too. Data is updated every 15 minutes because that's the cadence of most of the ionosons around the world. And I also put an X there for 3Y0J. That's where it is. One of the things you should notice, down around 3Y0J, the MUFs are maybe 20 megahertz. So that says that it's going to be a tough path down to 3Y0J on 15, 12, and 10 meters. Although our end of the path is good for 10 meters, their end is not. So that could be tough, but people have worked them. And like I said, the F2 region is dynamic and there are short-term events that we just don't predict. And you just got to get on and listen or watch spots and see what's going on. Okay, here's a forecast for 2023, and it's very general. The low band should be good at night. As we move up cycle 25, we're going to start seeing more coronal mass ejections and big solar flares, which could cause havoc with propagation on HF. We have to take these bad things with the good things being high sunspot numbers give us the higher HF bands. 30, 20, 17 should be good all year. 15, 12, and 10. They should be great for the winter and spring contests. Of course, winter's almost over. In spring here, pretty well, okay, it's really winter still. Next weekend is ARRL International DX at CW in February. March is phone. Those contests ought to be very good. Next fall and winter, CQ contests in October, November. We should have great propagation on the higher HF bands. So get on the bands. You technicians have phone privilege from 28.3 to 28.5, and you'll be able to work all over the world with modest power, 100 watts, and some simple antennas like a dipole or a vertical. Take advantage of it before cycle 25 hits its peak and starts going down again. Now, the IARU contest in July will suffer from degraded summer propagation in the northern hemisphere, and that's due to a change in the composition of the atmosphere. You can see there's a plot of how the MUF varies from Philadelphia to Germany throughout a year at a given solar phase. Fall and winter months are great. Summer months take a dip. But of course, in the summer, there's sporadic E, so watch for that. 10-meter long path. Here's some data from K9LA on the East Coast. And he worked a lot of JAs, Japan, and lots of VK6s, Western Australia, on 10 meters from January 79 through December 1993. So that's 2 solar cycles worth of data. And you can see the months that he had the most contacts, March through September, some October too. So that's why I said upcoming spring through fall, take a look at 10-meter long path. You'll be pointing your antennas, if you have directional antennas, to the southeast. Normally short path to JA and VK6 would be to the northwest. But for long path, point them the other way towards the southeast, and it'll be right after your sunset or your sunrise, and maybe a little bit after sunset, because there is a morning long path and an evening long path. Let's look at that. So here's K9LA's path to VK6 and JA. That's the thick black line. He's headed southeast. That's for an April month, and you can see where the terminator is. That may lead you to believe that long path is a gray line path. Gray line means the path aligns with or is very near the terminator. But he also made contacts in October, and his long path to the southeast is nowhere near the gray line. So it can happen from March through October, and you just got to point the antenna the right way. And here's the big picture for a 10-meter long path, and I'm sure this applies for 15 and 12 meters too. You guys are in the, well, so am I, in the pinkish vertical colorful box there. So what it says for morning long path, go to the right, and then you can see the longitudes that you should be able to work on a morning long path. It's Russia and Southeast Asia and Japan. Of course, Southeast Asia and Japan have, well, Japan has quite a few amateurs. Southeast Asia, not as many, and Russia, not as many. So a big issue with long path is there anyone on the other end? So that's your morning long path. You also probably have an evening long path. And over on the left, those are the longitudes you should be able to work on an evening long path on 10 meters, which you'll be pointing to the southwest. Europe through the Mideast. And all this whole picture comes from data from K9LA, from N6AV on the West Coast, from NT5C in Texas near Austin. And I also maintained skeds with JH3 Delta Papa Bravo back in '89. And one morning we had a 10-meter long path for 2 hours and 15 minutes. And that really surprised me. It was that long. But 89 was the peak of cycle 22. Lots of good sunspots to keep 10 open. And also the K index was very low. So the ionosphere wasn't disturbed. And that was really fascinating. We started at 6 a.m. in the morning, my time, checked every 15 minutes. And like I said, we went to 8:15. I had to get to work in a way. So that's good that the band kind of, the long pass signals faded away. I had to get to work. So have some fun. You technicians can take advantage of this too. And a lot of people are aware of long path. One thing that kind of I wonder about is a lot of those 10-meter long path guys are silent keys now. And I wonder if that has anything to do with 10-meter long path. Nah, I doubt it. Okay, whatever. Just a humorous comment, I guess. So here's a summary. Cycle 25 is awake and it's in its ascent. Hopefully it's going to get a little bit bigger than where it is now. Solar maximum will probably be around 2024, 2025. If the solar activity picks up significantly, solar max will happen a little bit earlier, maybe around 2024 sometime. But so far, and I can't stress so far, it kind of looks like another small cycle. But we'll see. But even if it is a small cycle, now and around solar maximum will offer worldwide propagation with modest power and simple antennas on 15, 12, and 10. So get on, have some fun. Of course, we're going to have more 6-meter F2 propagation as cycle 25 keeps ramping up. And that's going to happen in the fall and winter months that are coming up. Of course, the digital modes offer an advantage over CW and sideband because they can decode a signal farther down in the noise. That's a big deal on 10 and 6, where the MUF is very critical. And there are tools on the internet to determine what the bands are doing right now. So, if you go to DXMapscom and you see nothing's going on, then more than likely it wouldn't be worth going to check out what's going on, whatever. So, Mark, that's all I have. Like I said, I'll send a PDF of this. And if you guys would like, I could add a couple extra slides for the 3Y0J stuff. I've not heard them very well up here. We're at 41° north latitude. Thankfully, the last major 3Y0 Bouvet expedition was in December 89, January 90 at the peak of cycle 22. And I worked them on many bands. The higher bands were just excellent. Cycle 22 was about twice as big as where we are now in cycle 25. So that explains why 15, 12, and 10 meters can be kind of iffy right now, working Bouvet. And of course, as I understand it, they don't have their linears yet, and they don't have their big antennas yet. So it's kind of tough. Hopefully the weather clears up so more people can get on the island, and also they can put up better antennas and get the better equipment on the island. We'll just have to wait and see what happens. So that's all I had.
Carl, we appreciate it. We got a couple of questions, and I'm sure we might have some more. Just for your information, we've had a number of Bouvet contacts from the OKDXA folks coming in this way. So hold on, you'll be getting some stuff. I have one question. It was relayed to me here in Oklahoma. We're really fond of our meteorologists, our weather people. Yep. And the question is, they were worried for the safety of the solar weather people that are up on the sun in the hot weather, taking those readings. Can you talk about how those readings are picked up? Are they is a guy up there with an anemometer that's measuring solar wind? Yeah,
there's some guy up there sitting on the sun. He's got a nice, he's got a lot of ice around him. And oh no, wait, okay. Well, we measure the K index down here on Earth. It's how the Earth's magnetic field is varying. Sunspots and solar flux, we measure at ground level. Solar wind and that B sub Z, that's on a satellite that's on a line from the Earth to the sun. It's about 1 million miles away from the Earth. So there any other parameters? in there. Well, let me go back away here. Oh, come on there. Okay, there we go. My gosh, my PowerPoint's working. How about that? Okay. Extreme ultraviolet, well, that's measured with satellites above the atmosphere, because extreme ultraviolet, as it goes through our atmosphere, loses energy in the ionization process, and that's why we can't measure it at ground level. There's some other measurements that are done by satellites, but again, I think these parameters should give you a good idea of what could be happening.
Perfect. Thank you. They were feared for their lives. So good to know they're not going to be anybody passing on. How about Zoom? Anybody on the Zoom channel that needs to open up for a question?
Yes, sir. I was wondering more about the website that you had posted, the DXMaps PSK reporter, and I didn't get them all listed. So if you could show those, I'd appreciate it.
Remember, I'm going to send a PDF of this to Mark, so you don't have to copy anything down. Oh, okay. I can put, okay, on this page, PSK reporter, I can put their URL. I can put the WhisperNet URL. I can put the reverse beacon network URL and the IARU beacon URL on there too. I will do that when I send the PDF.
Thank you, sir.
Yeah.
Thank you for your preparation and presentation on this propagation issue. I have two questions. One, what makes scientists feel that earthquakes and other Earth issues have an effect on propagation? And the second one is I've had a heck of a time trying to even hear Bouvet.
Yep.
And so any suggestions about how we might be able to make contact with them?
Well, okay. With respect to events at ground level in the lower atmosphere coupling up the ionosphere, it's not that we think it happens, we know it happens. We can see signatures of earthquakes, hurricanes, etc., in the ionospheric data. Now, generally, it's of a small nature. How much that affects propagation, I'm not sure we can say that yet, because we just don't fully understand what's going on. But we can see the F2 region vary because of those events down at lower levels of the atmosphere, and also at ground level. So whatever. Okay, as for, well, assuming, I don't know what your noise, are you in a rural area? Do you have a low noise?
Yeah, low should be low noise. Yeah.
Okay, well, okay. If you didn't, well, you gotta somehow work on your noise or get antennas that maybe a directional antenna, of course, will reduce your noise because it doesn't pick up noise around the compass. Higher gain antenna. And sometimes you're in the wrong place at the wrong time and not much you can do.
Move.
Move, yeah. Well, you could use a remote radio too, to a more better area. You know, the DXCC allows you to work DX from anywhere in the United States. Whether that's an ethical issue for you, that's up to you, but there are ways to do that. I don't know what to say. There's nothing major that you could do except, you know, put up a, if it's for the higher bands, 15, 12, and 10, put up a, you know, a 6-element mono bander at 100 feet or something.
Question. You mentioned the 3 centimeter radiation. Is that the microwave frequency that's being measured?
What radiation was that?
3 centimeter.
3 centimeter. I don't recall mentioning a 3. Well, let's see here. Of course, I'm getting old.
Isn't it the 10 centimeter flux?
10.7 centimeter. Is that what you're talking about?
Okay, 10 centimeter.
Yeah, that's measured up in Canada.
Does that relate to the microwave frequency at 10
Well,
centimeters?
Yeah, that's the wavelength of the radiation that they're measuring is 10.7 centimeters, which is around 2,800 megahertz. And
Around
of course,
3 gigahertz. Okay.
yeah, 3 gigahertz. And that comes from, the 10.7 centimeter measurement started in 1947. And where it comes from is those surplus radars from World War II. And that's why 10.7 was picked, because that's what the equipment did. And it's a good measurement. It's a measurement. It's objective. The sunspot number is subjective because we count them. And how small a sunspot do we count? And there's human bias in counting sunspots, unfortunately, too. So SFI, solar flux, is an objective measurement. And again, it's a proxy for extreme ultraviolet.
Any others on Zoom have a question? Nope. Anybody locally have a question? One in the back. So hang on, wait for a microphone because he won't be able to hear.
On those parameters that below the ionosphere that nobody has defined as yet, is there any links to research being done on defining those parameters?
Well, in the peer-reviewed journals, Journal of Geophysics Research, Space Weather, Radio Science, the European Geophysical Union, there are a lot of papers on that kind of stuff. And I guess I can get into what happens is an event happens down low. It couples up to the ionosphere, the F2 region, and causes a traveling ionospheric disturbance. And what that is kind of wave-like motion in the F2 region. We can define the period of that wave, but trying to correlate it to how it correlate all that stuff in one simple formula is kind of tough. We've been, scientists have been working on this for about a decade, maybe a little bit more, trying to better understand it. And like I said, we don't have any parameters for that yet. So, parameters that we can use to input into the model of the ionosphere. And well, hopefully something will happen one day.
I've raised my hand.
Go ahead.
He's not tooting his own horn, but if you go to K9LA.us, there are several links there to
that's right.
propagation stuff. It's still, this is not passé stuff, that this is being studied all the time. Some people tend to think of HF as being old fashioned. Well, sure, but space weather is a big deal.
Yep.
And people are studying the ionosphere all the time. And K9LA.us has links on there to some of that research. I'll also plug the HamSci guys.
Yep.
They are doing amateur data collection, amateur radio data collection for this stuff. When he mentioned traveling ionic disturbances, I thought, oh yeah, that's one of the areas that they're studying.
Yep.
So yeah, there's a lot of stuff online to get into that research if that's what you want to do. There's a lot of very strange little Greek symbols there that somehow add together to be other Greek symbols that I don't understand, but you can kind of get the gist of it by reading it.
Yeah, there's quite a bit of information out there, and you got to sift through it and which ones are important for us. Space weather is important for space travel, for astronauts. It's also important for orbits of stuff going around Earth, because at solar max, there's more drag. That means the orbit's going to be affected. And, you know, speaking of ham SCI and a lot of the stuff in the peer-reviewed journals, we're just in the measurement phase right now and trying to understand how it couples up. I'm not aware of anyone who has tried to tie that to propagation yet. You know, something simple, which who knows, it may not be that simple. It may be several, for the events in the lower atmosphere, it may turn out to be several parameters that are tied together. Instead of, you know, like solar radiation, we could use sunspots only. Geomagnetic field activity, we could just use the K index. That would be good enough, because for those two sources, those parameters are kind of very well tied together. But for the events in the lower atmosphere, it may be that we need more parameters that define a bunch of things. So I'm not sure, like I said, I'm not sure anybody's thinking about that yet. Oh, okay, what I'll do is add a slide of references. Like you mentioned, the ham SCI stuff, I can give the URL there. There's some good books out there. Let's see, 921. A couple of years ago, I updated the CQ propagation book, the CQ shortwave propagation handbook. It was the last version was 1995, so a lot of stuff had happened in 35, 45, no, 95, 2005, 2015, 20, 30 years. So that's a book. You got to buy it though. On my website, I have Bob Brown's book, the Little Pistols Guide to HF Propagation. That book is out of print. Bob is in silent key, but that book is on my website as a PDF, and there's a good start for free.
Nothing here. No hands are up in the air. So Carl, I really want to thank you on behalf of all the folks that are here.
Yes,
Give them a round of
very much so.
applause.
Okay.
And we appreciate all your efforts. You are welcome to stay if you wish, but you've probably seen 8 million hammer radio meetings and they're all about the same.
Okay. Yeah. Well, thank you for letting me do this. If you got any topics in the future that you would like me to drill down into, I certainly can do that, or talk about antennas or de-expeditions, something like that, whatever. So
A volunteer. We always love those. Thank you.
yeah,
Appreciate
no
it.
problem.
Thanks
Okay.
a bunch, Carl. Appreciate it.
Okay, I'll leave
Thank
here.
you very
So
much.
Let me stop sharing, I guess I should do
Okay.
that.
Thank you, sir.